हाँ रे. We can start.
Hello, sir.
We can start.
Okay, sir.
Getting the proper output.
Yes, sir. I might well, sir. You can start.
Should I start?
Yeah, you can start, sir.
Okay. So I welcome all of you here.
Okay, sir.
Getting the proper output.
Yes, sir. I might well, sir. You can start.
Should I start?
Yeah,
Okay.
you can start, sir.
Okay. So here we are with this topic, and I welcome all of you again. We have some technical glitch, and okay. So let's begin the session today. Okay. So the topic is the new topic added, and I'll be concentrating on that new topic. And that has something to do deal with IR optimization, and I'll try to cover as much as topic as I can today. So where we are here. This part. This part is the where we are intermediate code generation, and then finally after intermediate code generation, IR generation, we start optimizing it. Code generation and code optimization. Okay. So here we are having the goal is improving the IR code. Okay, the improving IR code by the IR code generated by the previous step to take the better advantage of the resource. Okay, this is the whole idea, that taking the improving the code and taking the better advantages of the resource. Now, why we have to do this thing is the first reason is IR code is generated by machine, and it may introduce redundancy. So there may be some redundancy present, and then we will see a naive translation of high level language feature into IR often introduce subcomputation. Okay, subcomputation. Subcomputation can be speed up, shared, or eliminated. Okay, this subcomputation can be speed up, shared, or eliminated. Okay, so this is the idea of IR optimization. Uh, Redundancy can be here. Suppose we have a three Boolean variable, and this three Boolean variable is something like this: x plus x less than y, x plus x exactly equal to y, and x plus x is greater than equal to y. The code will not the code. Yeah, good evening, Bhanu. So code will not look in this way. You can see here that when you manually when you generate, you can see that x plus x has been used many times. But when IR will be generated, there will be one temporary register T0, and that will be adding the value, then T1 y, and then it will compare the less than. Then another temporary variable will be taken, and that x plus x will be over here, and then again it will check for the this condition, and again T4 another temporary variable, and that will test again for the less than or equal to. Okay. Now immediately you will observe that we have some scope of improvement. There is a scope of improving this code, and immediately comes in your mind that why to compute x plus x three times. If I am checking the condition with x plus x rather than writing this again T2, I can write here T0. I can write here again T0. Okay. So this this is an example. Later we will see. This is the elimination of common subexpression. Common subexpression. Okay, so this is one thing that we want to do. So similar thing is highlighted over here, and this is also why we are assigning it, and y value will be again, if you see that this same variable has been used again here in this case. So we can definitely improve this thing, and we can get a better IR that will utilize the resource in a better way. Another reason is reason 2 is programmers are lazy. Okay, so that's lazy programmers are there. Code executed inside the loop. Inside the loop can often be factored out of the loop. So often the programmer, from programmer point of view, that we can take the code outside of this loop. The meaning of this is this one. Suppose this is the condition that we are testing, and x less than equal to y plus z. Okay, and this we can this condition will be tested again and again here in this case. So here the code is written in this way: t0 is equal to y plus z, and t1 will be x less than equal to t0. So this is a TSC, 3 address code, and I feel that you know the how to generate the 3 address code in this case. Okay. So and if 0 and nz also t1, then go to L1. Means if 0 means the condition is false, then we can go to L1, and this is taking outside of it. Okay. Otherwise we do x and x equal to x minus 1. Now within this you observe that this y plus z will be executing again and again. Okay, x though anyway modifying here in this cases, but y plus z, look at y plus z here. So this is y plus z, and it will be executed again and again. And here this particular lazy coder, we can take this outside of it, and still it will work. Okay. So again, it's about utilizing the resources, and this computation where it doesn't depend on the loop. Okay, this condition, look at again one more time this t0 is equal to y plus z. This computation is called loop invariant computation. Loop invariant computation. And what is the loop invariant computation? Is that it doesn't depend, its value is constant. Its value does not depend on this particular loop. Y plus z is a constant, and it is not changing based on this execution of this while loop. Okay, so that's why what we can do, we can take this thing outside, and only one time computation, and there as many as time while loop will run, as many as time this will be computed. Okay. So now this is also one of the optimization technique, and that is called taking the loop invariant computation, and that is your code motion. Okay, so we can move the code outside, and that's why the very uncommon name, code motion. Okay. So language features with side effects often used for this purpose other than those side effects. Why we do this thing? Observable behavior and as efficient as possible, and should not take too long to process the input. So this is the core reason, theoretical aspect, that a good optimizer, okay, never changes the behavior. Okay, it will not change the observable behavior, that you are not changing the program, you are making it efficient, and it should not take too long to process the input. Unfortunately, this process, some optimization process may sometime may introduce bugs. Trying to make it easier, and it may be sometime always not possible. So in that process, it may introduce bug, and it's often miss the easy optimization. There is a simple way, and we always try to find the hard way. And the last is all the interesting optimization falls into the category of NP hard or undecidable problem. So these are the challenges that we are having. Okay, and already I told you why we need to optimize is making the program as fast as possible, okay, and it will increase the generating the smallest possible executable code, and that will reduce your memory uses. Power consumption, and right now, so now most of the time nowadays machines are running on batteries, so speed and memory uses, we want to also concentrate on this patterns, and that's why these optimizations are necessary. So two aspects are there of IR optimization, intermediate code optimization: machine independent optimization, O is missing, optimization, and machine, okay, both are independent, more machine dependent. Okay, so machine independent and machine dependent optimization. Before I begin with this course, we have to just look at once the basic block and flow graph, and there are few questions from this basic block and flow graph topic. So what is a basic block? Basic block is a maximal sequence of 3 address instruction, and I believe again that if you are not familiar with TAC, 3 address code, which I will not ask you to convert here, what I want you is that just concentrate on the process part. If you don't know TAC, this is very simple. 3 address code is very simple. There are few rules are there, and we need to follow those rules. But now concentrate on this part where we are using the optimization IR. It is this topic is assuming that you have done with your 3 address code, and we are just making sure that any other thing other than 3 address code, how we get into this IR thing, that topic is stressed most over here. So we want to find out first thing is the basic block, and that is the maximal sequence of 3 address instruction. Okay, maximal sequence, grouping of 3 address instruction, which is having a property that flow of control can enter the basic block through first instruction without branching and halting. Without branching and halting. That means there will be no jump instruction in the middle of the block. So what is a basic block? Maximal sequence of the 3 address instruction where control will enter from the first instruction and control will come out from the last instruction. In between there will be no branch, jump, and there will be no halt. Okay, so that we call this as a basic block. That is the same thing here. Control will leave the block without halting or branching except possibly the last instruction. So we are interested in what? We are interested in 3 address code generated by a compiler or that phase intermediate code generator. We are dividing the entire 3 address code into basic block. Flow graph, and then we will just translate this into a control flow graph. So definition wise, what is a flow graph or control flow graph? So in this control flow graph, both are different. The basic blocks becomes the node of the flow graph. So for understanding the flow graph, what you need to do is you need to find the basic block, and each basic block will become one node. One node of what? One node of your flow graph. Edges indicate whose edges indicate which block can follow another block. So there will be a flow of what? Flow of control. That is the simple thing. Flow of control between what? Between your basic block. Okay, so control flow graph, CFG. Right now CFG is not a context free grammar. I'll use the term CFG, the abbreviation for control flow graph. And in flow graph, we have a dedicated node for the start and exit. The moment we'll have the dedicated node for the start and exit, then the same flow graph will become control flow graph. These are the definition, and this is the first thing we need to learn is what is how to design a flow graph. That is the first thing we'll learn, and after that we'll convert into a control flow graph. But for both of this thing, first we need to identify the basic block, and a bit interaction will be there, so be prepared with this answers here in this case. So we will determine now the basic block where the input will be 3 address statements, and what will be the output? Output will be your basic block. of the three address statements. For that we will find the leaders. For that we will find the, yes Banu, your assumption is correct that we'll have a flow chart without halting. There will be no jump in this case. There will be no jump in this case. Just be with me. It's very simple topic. Uh, so we need to find the leader, and there are few rules are there. Where we'll find the leaders from our TS, yeah, three address code. So from three address code, we'll find the leaders, and who is the leader? The first statement is the leader. Okay, the first statement is the leader. Second is any statement target of conditional or unconditional go to. Okay, so if there is a target means the meaning is go to, let's say a label L3. Huh? So if it is the target, okay, target of the conditional and unconditional go to, that is also a leader. Last one is the statement immediately follow a go to or a conditional go to statement is a leader. And don't think in terms of that in C language we are not allowed to use go to, but TAC, three address code, use only go to create branches. Okay, but it is a systematically used. Okay, so first statement is a leader, target of a branch instruction is a leader, and any statement immediately follow go to or conditional go to is a leader. Now here I have taken a program which is, and you don't need to do the three address part. You don't need to do this thing. And real valued array element takes few assumption is there, and I think it is not 8 byte each, and matrix is stored in the row measure form. So this is the program. Okay, and I have already done it. You don't need to be worried about this. I could have skipped this slide also. And this is the your program, three address code. This is the three address code. And what we'll do here in this case is, in this three address code we'll apply our algorithm, but before that we will just identify the leaders. Okay, so I'm using the statement, and let me just be with let's just listen it carefully. The first statement is a leader. Okay, leader, L is for leader. So the first statement is a leader, so the statement number one is a leader. Then target, the second rule is what? The target of conditional or unconditional go to. So this is your conditional go to, that if j is less than equal to 10, then go to 3, the statement. So this is a conditional go to, and the target here in this case is the third statement. So target of a conditional or unconditional go to is a leader. So this is also a leader. Okay, this is also a leader. This is again a conditional go to, I less than equal to 10 and go to 2. Target is 2. So statement number 2 is also a leader. Okay, so this is the second rule. Go to 13. Okay, go to 13, and this statement 13 will be also the leader. Okay, so this is also a leader, statement 13. So now what is the rule? The target one. Okay, the target of a branch instruction. So target for the branch instruction in this case is also a leader. This is for the second rule. The first statement is leader and target is the leader. The third rule is any statement immediately follow a go to or a conditional go to is statement is also a leader. So who is following the conditions and unconditional statement? Please tell me now. Interaction response needed here in this case from your end, that which statement, which statement will be a leader if I apply rule number 3, the statement after conditional or unconditional branch instructions. So who will be leader in this case? Please respond here. Who will be the leader? Okay, Bhanu. Bhanu, 12, only thing is 4 will not be a leader. 4 is not a statement followed by the conditional branch instruction, Bhanu. Okay, so understand that here, uh, absolutely correct that this will be a leader. 10, why? Because it is coming after this go to. 12 will be a leader, absolutely correct here in this cases, because after this there is a, and after 13 we do not have any other instruction in this case. So only the statement number 10 and 12 will be a leader. Okay? The statement number 10 and 12 will be the leader. 14. Okay, 14 is also not followed by any branch instruction in this case. 14, after 14 also there is no branch instruction. So we apply 3 rule. First statement, any statement after the target and after the branch instruction. So 2 and 3 is because they are target, 13 is because it's a target, 10 is because it is following 9, and 12 is it is following 11, which both cases a conditional go to statement. So now once you identify the leader, then now you can convert into a basic block in this way. This is a leader and second leader is the second statement. So this will be alone a single statement as a leader. Second statement itself is a leader. So now this will be only one, because from the next statement another leader starts. Okay. So one, after that next leader it statement 2, so only one statement. 2, after that the next leader start from the statement number 3, and that's why only 2. And 3 till you get a new leader. So after 3 you are getting the new leader at statement number 10. Okay, so from 3 to 9 there will be a, all will belong to a single leader in this case. Okay, so this not leader, a single block. So 3 to 9 will be one block. Okay, now coming back to this 10 and 11, both will be 10 and 11. So this is another leader is at 12. So 10 and 11 will be one group, one basic block. 12 will be alone statement which with one basic block, and 13 to 17 will be your another basic block. Okay, so what is the idea? That till you get the next leader, till next leader, okay, till next leader, every statement belong to a one basic block. Every statement belongs to one basic block. Okay, so one basic block. Sohini Nandi, welcome Sohini. Okay, so now I hope you understand that how many blocks we are having in this case. If I name as B1, block number 2 basic block 3, B4, B5 and B6. So there are 6 blocks are there. Okay, now flow, let's decide the flow. That these are the flow. Let me put the different color over here. So this is the flow will be here to here. This is a linear flow. Linearly the control will flow in this particular case. There will be more flows due to this jump instruction, and due to this jump instruction it will also have now consider this go to third statement. So there will be one edge from here to here. Okay, block number 9. Okay, this is to the target is 3, and there will be one edge from here to block statement 2, and there will be one edge from here to here. Okay, this is your flow graph. Okay, this is your flow graph. Okay, this is the flow graph. Now what you can do, you can convert this thing into a control flow graph. And now this diagram and this diagram is same. Okay, look at this instruction to this instruction, and then here to here. Total number of six blocks are there. It is more formatted, but this is the same thing. The only thing is this is your flow graph. Okay, this is the flow graph. Very subtle, not subtle, very trivial difference. This is a flow graph, and you add 2 points, entry point and exit point. You add 2 points where the control is enter, and it will exit, and this will, the same flow graph will become control flow graph. Okay, the same graph, flow graph, will become control flow graph, blah blah. But do not forget to add these two nodes, huh? Okay, entry and exit, do not forget to add this one, huh? This is becomes your control flow graph. Okay, so first question that was asked in the gate examination, and I'm just getting it for you. Till that you fetch this one, understand this one is control flow graph, huh? So just give me 1 minute. Look at the statement and please let me know whether it is clear to you or not, huh? Very simple thing, very simple thing. This question, question in front of you. Entry and exit is the control point where control will enter and it will leave, huh? So you cannot have what without where what will happen after this, huh? Control will flow and where the control will end, huh? So that is important in terms of control flow graph, huh? And be very careful with this, huh? Be very careful with this. This is one of the question in asked in 2015 about this control flow graph, huh? So please complete this problem and let me know that how many nodes and edges are present in control flow graph, huh? Saksham, I was just explaining this control flow graph and control flow graph. If you don't know, then I will repeat it, huh? Because it's very small thing, and later also you can watch it. Okay, great, Saksham. We are done with this. Very good. So you haven't missed anything, huh? You haven't missed anything. I just answer. Please answer this question. Very good. Saksham is ready with the answer. Okay. B is the answer. Very good. So this is the leader. Uh, 2 is a leader and 3 is also a leader. Very quickly you can identify that these are the leader because of first statement and target. Another thing here in this case is any instruction after the branch instruction, and that will means that this will also be the leader. Okay. Here only one statement, statement number 1, and here the statement number 2, and then you have a 3 to all the way to 9. So 3 to all the way to 9, and then we have 10 and 11 in a one group. Okay? 10 and 11 in a one group. Flow will be like this: 1, 2, and then this flow. Then we have a go to statement number 3. So we will add this one, and 11 is having go to 2, so we'll add this one. One entry is there and one edge is for exit. That two nodes are important and you have to add it, otherwise you can understand the answer. 1, 2, 3, 4, 5, 6 and 7. So there is 7 edges, and the number of nodes is 1, 2, 3, 4, 5 and 6. 6 nodes and 7 edges. Okay, so that is the answer. B is the answer. Very good. So I hope I am clear with this, and I did not take much time here because I believe that you are more or less familiar with this. And if you're not, then this is the only question we are having, and it is simple. You have to find leaders and then you have to convert into a graph. Do not forget to add entry and exit. Okay, we will not do this one. We will we'll directly come to this part. Okay, I hope yeah. So now we are coming to the optimization, and there can be two type of optimization: a local optimization that works in a single basic block, okay, and the global optimization if we are working on entire control flow graph. Both. So now this is a very different meaning, that when we are doing optimizing a local block, single block, that is a local one, and if you are working on the entire control flow graph, and that is your global one. So now here this is one of the flow graph designed for this, and if you can see here, yes, this kind of the codes for equality. Generally we do not think equal as a, when we write 3 address code, we don't consider this thing. But look at here, this code is yes part and no part is there, else, if and else part. So this code is t1 equal to y, t1 equal to y is equal to t1, t2 equal to y, and x equal to t2. Okay. So now here we can directly write what we write. Then we write directly z equal to y, but IR don't write in this way. It's a machine generated code, so each assignment it treated differently. So in this case, only thing is okay, it is working on this. So here y is equal to 137. So for this one, t0 to 137, y to t0, that it can write directly y to 137, and that is one category, that is called copy propagation. Okay, copy propagation. Okay, and later we will do this one. And again, this one, t1 is equal to y and z is equal to t1, and that can be z equal to y, t2 equal to y, x equal to t2, and x equal to y. So they are working on local level. Globally, what we can do? Globally, we can do this, that we can, instead of y, what we can write here, z is equal to y. There is a scope of a global optimization, and we can write the value, both the value to 137. Okay. So local optimization work with what? Work with basic block. Okay. And global optimization work on entire control flow graph. Okay. Entire control flow graph. So this is the basic definition of what I explained you: the local optimization and the global optimization. So again, if you have think that I have done something very difficult, please look at this. These are the assignment that is happening. Y is equal to 137, z is equal to y, x equal to y. Instead of using a temporary variable assigning to y and z to t1, and here also the same, we can use this z is equal to y, and here also x equal to y, and here also y is equal to 137, and then we can propagate this copy which is in a different block, 137 here and 137 here. local optimization. Look at the local optimization. Okay, now if these are the code of basic block, the first local optimization is common sub-expression elimination. Okay, common sub-expression elimination, and I'll give you the algorithm after this. Algorithm after this, but idea here in this case is so here what is the idea, that here B is assigned with the value A star B and C is also assigned with the value A star B. These are the common sub-expression here in this case, and instead of writing this okay A star B to B, we can directly assign the value without any computation because it's already been updated. C is equal to B. Common sub-expression continue. So now here in this case, if we have two variable assignment, v1 is equal to A operator B, v2 is equal to A operator B, and the values of v1 A and B have not changed between the assignment, then we can rewrite the code here in this case is v1 A operator B and v2 to v1. Similarly, we can also apply the similar transformation of the basic block, and here in this case is A is equal to B plus C, B is equal to A minus D, C is equal to B plus C, and D is equal to A minus D. Okay, can we apply the similar transformation? So here the idea is what, that here there is a B plus C and here there is a B plus C, but in between the B value is changing. In between the B value is changing, and if you say that can I write A over here, the answer is no, you cannot write the A value over here. Why? Because B has been transformed and we cannot do the similar transformation to this basic block. Answer for this case is no, we cannot do this thing. Copy propagation is another and they go hand by hand. This common sub-expression elimination, common sub-expression elimination, and copy propagation. Okay, copy propagation, they go hand by hand in this case. Okay, so what is a copy propagation? If we have a variable assigned v1 is equal to v2, okay, as long as v1 and v2 are not reassigned, okay, we can rewrite the expression A is equal to v1, and because this is a copy, which copy? v2 has been assigned to v1 and again we are assigning v1, so we can write this thing as A is equal to v2, provided this rewrite is legal. This is very simplest form you can say, of this transformation. So v2 is assigned to v1, so instead of writing v1, we can just write here v2, the assigned value we can write it over here. Yes, okay, and right now it looks very simple, but it helps immensely. Later you will see that this thing, simply propagating the copy will help immensely in this case. Okay, so this is copy propagation. So A is equal to v1 and v1 is assigned to v2. Okay, v1 is equal to v2 and we can rewrite A is equal to v2 in this case. So two things I said here, common sub-expression elimination. I said A star A and B, and this expression can be eliminated entirely by assigning B, provided value is not changing. And if we have this is the theoretical aspect of it, we can change it, and here we cannot apply it because B value has been changed here and we cannot now say that it is the same value. Second is your copy propagation. v1 is equal to v2 and v2 value is assigned to v1, and A is equal to v1 can be changed to A is equal to v2. So applying the copy propagation here in this case is now this is a common sub-expression C is equal to B. Okay, the B has been assigned to this value over here, and now instead of this C, what we can rewrite here, we can, because this copy is assigned over here, and please remember that whatever we are copying, that will be replaced. So here in this case, copy propagation will change this value to B. And after that again we can apply what we can apply here, again common sub-expression elimination, and we can apply this common sub-expression again, and instead of E is equal to this I can write E is equal to D. Okay, so this is something that is two part, and with that both are go hand by hand, common sub-expression elimination and copy propagation. Okay, am I clear with this? Please let me know once your comments that is this okay. Both are clear? Please respond one time. Common sub-expression elimination and then copy propagation. Take it. Okay, now then the next which is written in your syllabus is dead code elimination. Okay, dead code elimination. An assignment to a variable we called dead. Okay, so we have a dead definition of dead variable. Definition of dead variable. An assignment to a variable v is called dead if the value of the assignment never read anywhere. So now there is an assignment, let's say a is equal to b, there is an assignment, then the only utility of this assignment is this someone will come and read the value of this a, read the value of a. Okay, read the value of a. If no one is reading the value of a, then this assignment to variable v is called a dead assignment. This is a dead assignment. So someone must have been reading this value, otherwise this will become a dead assignment. Great, thank you Prathamesh, Anurima. So it becomes a dead assignment. So it's about what is a dead variable. It is nothing to do with the dead code that not reachable and all. This is having completely different definition, that if you are assigning something to a variable and no one is reading it, then that assignment is a dead assignment. Dead code elimination removes the dead assignment from intermediate code. So we are removing the dead assignment. Dead code elimination is not about unreachable code or removing the unreachable code. It has nothing to do with this. It is about removing the dead assignment from this intermediate code. So here, okay. Now, if you look at the assignment over here, C is equal to B. This assignment, if you see, within this basic block, C is equal to, within this basic block, we are not be able to read the value of C. No one is reading the value of C. Only B is being read over here, and then D is read over here. Now you understand the read and write, reading and writing it. D is updating, E is updating, and here in this case B is read and D has been read in this case. So now C is not read by any in this particular basic block. Okay, by any assignment. So this assignment for this particular block is your dead assignment. This is your dead assignment. Okay. So I hope you understand the dead assignment. Okay, so now what is this? This is not the algorithm part. This is not the algorithm part. This is the introduction. So three things that is written in the new syllabus was a common sub-expression elimination. Okay, that was first thing, common sub-expression elimination. Second thing that was written over there was copy propagation, and third is your dead code elimination. Okay, dead code elimination. Okay, so this three thing I hope we are done with this, huh? But this is not algorithm part, huh? This is not the algorithm part. Now we will apply the uh, algorithm into this, huh? Implementing the local optimization, how we are going to implement this thing. Okay, so the first analysis that we are going to do here is a framework data flow analysis. Already I told you that about the data flow analysis, uh, and flow analysis and data flow analysis, huh? So within that, what we are going to do, we are going to do the this analysis and optimization, and what we are going to do is, for implementing your first two part, that is your common sub expression elimination, we are going to do the analysis of available expression analysis. Okay, so common sub expression elimination, this is the algorithm part, huh? That was the theory part, this is the algorithm part, how we are going to do this. Common sub expression, and what was that, copy propagation. Okay, for this we will do the available expression analysis, and live variable analysis is liveness analysis, that is also written in our syllabus. Liveness analysis is for the dead code elimination or dead code assignment. Okay, so we have to do two algorithm to understand this. First is your available expression analysis, huh? Available expression analysis. But just give me 1 minute so that I can ask one question. uh, okay, so I think you're ready for this, and I can you can answer at least this particular question. Let me say this question to you, and that information will be, how it is so basic question asked in the examination. See by this, huh? So look at this particular question, one of the gate question. Let's complete that one, and then we can move ahead with our algorithm part. Okay, so look at this part, just 1 minute, huh? Now we are implementing it. Don't hang. Okay, so look at this particular question, and I think you will be able to answer this one now. This one, please go ahead and solve this particular question. This is 2014 question, where entire thing was there in the syllabus, and it is the right time to discuss this thing. Before that, I told you this thing, that you remember that we will do two type of analysis, which is available expression analysis for common sub expression and copy propagation, and we'll do the live variable analysis for that code elimination. Look at this question and answer. Please answer this one. Okay, so okay. So Umesh Pathak is here with the answer as D, and Bhanu is saying B. Okay, Prathamesh is saying in this case answer is D. Great. So here false. Okay, false. So what I just said here is a basic block is a sequence of instruction whose control enter the sequence at the beginning and exit at the end. This is the basic definition of your basic block. True. Available expression analysis, that will do. We have not done, but I just told you that available expression analysis is used for common subexpression elimination, and as well as what, as well as your copy propagation. Okay, copy propagation. Live variable analysis is used for dead code elimination, that we have not done, but we will do it. True. X equal to 4 into 5 is equal to x into 20 is a common subexpression elimination. No, we are not eliminating the common subexpression. This process is not a common, after that at least you will understand that this is not a common subexpression elimination. This is something that is called as constant folding. I'm just giving you more information, but right now we do not have that analysis. This is called constant folding. Every time computing and then putting the value. This is not a common subexpression elimination. This is a constant folding. Okay, so you must have analyzed that this statements are true. So ultimately, even if you don't know, you have to go with, in this case, is D as an answer, and which is false. Okay, so D is the answer for this particular question. Most of you have done. Bhanu, I hope you understand that B is not the answer. D is the correct answer for this particular question. Okay, so that is not a common subexpression elimination. Great. So moving forward, and now next is your available expression analysis. And what we do here, we do common subexpression analysis and copy propagation. Two things we do here in this case. An expression is called available if some variable in the program holds the value of that expression. Okay, an expression is available, okay, if some variable, so like here a is equal to what we have done, b plus b. So this expression is available if some variable holds the value of that expression. So a is available. A is available here in this case. Okay. In copy propagation, we replace use of a variable by the available expression it holds. We replace use of a variable by available expression it holds. So we replace it in copy propagation. In common subexpression elimination, we replace the available expression by the variable holding its value. Okay, by variable holding its value. So right now let's concentrate on one part, and I'll explain you with example. It will be clear too. But by definition, in common subexpression elimination, we replace a variable. Okay, variable expression, an available expression by variable holding its value. Okay, by variable holding its value. So let's see, and then we'll come to this copy propagation definition. Let's first complete the common subexpression. So finding available expression, initially no expression will be available. Okay, for when we start doing it, no expression will be available. When we execute the statement a is equal to b plus c, any expression holding a will be invalidated. Means previous expression, if a was holding a was modified, suppose b plus b, and after that you are coming to this, then this b plus b will be invalidated, and the expression a is equal to b plus c becomes available. Okay, so we are dealing that where it is available in the variable a, this entire expression is available. Idea is what? We iterate across the basic block from beginning with empty set of the expression and updating the available expression at each variable. Okay, so we will be iterate down from this basic block and with empty set and updating the available expression at each variable. So now this is the theory part. Theory always sound confusing to understand, but let's understand with an example here in this case. This is the entire, let's say, entire basic block. Entire basic block. Okay, so we'll start iterate down. We'll do the multiple iteration, and you can do it by in one iteration also. You can do this thing. So initially no expression is available, and after that a is equal to b is available. Okay. Then next expression that is available is equal to c is equal to b is available. Then d is equal to a plus b is also available. Then here e is equal to a plus b is also available. Okay, now here, now d is equal to b. Now right now d is holding the value of a plus b. Okay, d is holding the value of a plus b. This will be invalidated, and this will become d is equal to b and e is equal to a plus b. Available expression, what is the available expression? And finally the entire expression is now available over here. Okay, so I'm repeating it, what is available, what is not available here in this cases. Initially we'll start with an empty set, and in this case a is equal to b, so a becomes b becomes an available expression. C is equal to b, yeah, it is also available. D is equal to a plus b, that is also now available. E is equal to a plus b, that is also available. Now when you say d is equal to b, so in that case this d assignment, that is a plus b, will be invalidated. So now here d will be gone, and now only d is equal to b is available, and here entire expression is available. Now so here what we need to do is a is equal to b, common sub-expression elimination. How we do this thing? So what we have done, so here now this b is been assigned to a. Okay, this b is been assigned to a, and here we had this expression what okay, we have c is equal to b, and this b is assigned to the variable a, and a is equal to b is a available expression. I'll use this expression, and now I'll eliminate this b because b value is been assigned to a, so we'll use here in this case c is equal to b. Now at the next stage, the expression that is available here in this case, a is equal to b and c is equal to b. Okay, next. After this, d is equal to a plus b is a available expression, and here the expression is e is equal to a plus b. So now what we can do, we have the available expression a plus b holding the value in this case is d, and instead of this you can guess that we are going to write here d. The available expression here was e is equal to a plus b, and here d is holding the value of b, and you can see here that b is been hold here in this particular case as b and a. Okay, so why b and a in this case? Here particularly d is equal to b. Okay, let me go back. D is equal to b is there, and here e is equal to a plus b is also available. Now here this b is there, and this b can be replaced by what? This b can be replaced by your a. We have to iterate down multiple times. We have to iterate down multiple times. Here the available expression is e is equal to a plus b, and in this case f is equal to e. Okay, so now this is what it will become after a single pass. Okay, this is what it will become after a single pass. Repeating. Okay, repeating here in this case. Okay, so this is the entire expression that we have designed, and now we are going for this elimination. And here when I come to the statement c is equal to b, this is an example of common sub-expression elimination. How we are doing it? So c is equal to b, and in this case b value is assigned to a, so we'll replace it by a. Here d is equal to a plus b, c is equal to b, so no expression is available for this, so we will not touch anything into this. But now d is equal to available over here, so for e is equal to a plus b, we can replace it by here by the value of d. D is equal to b. The first expression that is available, two expressions are there. I can understand confusion part, but we'll go with the first expression available, and that is your, this b will become a. F is equal to a plus b. This is available, and we'll replace it by e. Okay, and done. Next is so this is something that is common sub-expression elimination available expression analysis. Comment from your end. I think we must have okay, wait, liveness analysis, we'll do it later. Okay, so this is equivalent to both of your part, the elimination of common sub-expression as well as this. If you look at the entire example in this way, okay, then you can understand that what exactly we have done here in this case. Erase. Okay. So copy has been propagated here. B is equal to A, to A is equal to C, D is equal to A plus B, to D has been replaced over here. Like here what we have done, C is equal to A we have done, D is equal to A plus B, we haven't touched this one, D is equal to A plus B, and E is equal to D, so we have done A is equal to D, D is equal to B, and the copy of B is hold where? The copy of B you hold here in this case is in A, so D becomes A, and F is equal to A plus B, and A plus B the copy is in E, F becomes E. Okay, so this is your final expression becomes both, though I have written the heading as common sub expression, but copy is also propagated, copy propagation also done, okay, as well as your elimination of common expression also done, common expression also eliminated, so both are done in a single time. कमेंट कीजिए. कैसे बात करूंगी? Okay, so I hope that is example. And this is done manually, and here you can do it by yourself also, or इतना algorithm ना analysis करके that B copies in A and B is assigned to A, तो B is available in A, so we assign this C is equal to A, D is equal to A plus B अभी available है, E is equal to A plus B, that expression is available, and then we can assign E to D. D में फिर से B की copy जा रही है, but we know that B is assigned to the value of A. Okay, so we'll write here D is equal to A, and here F is equal to A plus B, so F is equal to A. Okay, okay, so that is something which is available expression analysis in this particular case. Okay, so this is manually we have done, and this is the final code that we got here in this case. Please comment here. Only Bhanu has commented. It will be better if I could have taken more example, but only thing is that we can work on any other example also. Let's see, practice part we'll do later, but at least this part must be clear to you. Okay, so the next analysis that we are doing, and manual is also possible and this way is also possible, but here the analysis corresponding, the next analysis corresponding to the dead code elimination is called the liveness analysis. Okay, liveness analysis, and I already told you that value must be read before it is written. Okay, it is written to again. Okay, so someone must have been read to that particular value. A dead code elimination works by computing liveness of each variable, then eliminating the assignment to the dead variable. Okay, and this is also an analysis that we will look at here in this case. To know if a variable will be used at some point of the time, we iterate across the statement of a basic block in reverse order. So when we done the available expression analysis, when we done the available expression analysis, we iterate down in what? Forward order. Okay, and each time we are maintaining what expression is available, and if it is if it is a copy, then we will just copy that expression and use that variable instead of that expression. So if for expression also we are doing it, and if it is a copy, then also copy we are propagating it. So both go hand by hand in this particular case. Now if a variable we have to traverse here in this case is not a forward order but the reverse order. Initially some small set of value will be known to live, okay, which depends on a particular program. So now here, because we are doing for some intermediate basic block, we assume that some random variables are live there, and this is purely based on, it is given something, some statement which is given. Okay. Now how to compute live variable? When we see the statement a is equal to b plus c, when you look at this statement b plus c, then you are reading the value of b and you are reading the value of c. That means just before the statement a is not alive, okay, since the value is about to be overwritten, and just before the statement value b and c are alive. So if we are reading the value, then it's a live variable, and if we are assigning the variable to a next updating the variable, then a is not live. So before that a is not alive, since we are updating it over here, and both b and c are alive. Now, so liveness analysis, since this is the same expression that we have eliminated the common sub-expression, same example. At this point of the time, we'll assume that b and d. Where b and d is coming from, that is something that is given to us. Why I have taken b and d? It is something that is given, that at this point of the time, some variable will be live. Now, so we are assuming that in this program here, when I go in traverse in the reverse order, okay, so now it is reading the value of e and f is being updated. Okay, so this, for at this particular instance here, just before the statement, e will be live and f will be dead. This bd will become bde. Please interrupt me if you're not clear with this live variable analysis. If you are not clear with this, please interrupt me here, that this to this, b and d is live, and then we are reading the value of e. So e will be live and f will be at this particular time, because f is about to update, f will be not alive in that case. So this set will become in the reverse order. This will become b, d and e. Comments? Please see, interactions are important, so that like do not even write it down. Maybe I'll receive that late, your messages, but anyway I'll try to rectify it. So so we are assuming एक statement है यहाँ पे, that in this case reverse order, initially some small set of values are known to be live. So in this case we know that some set of value is live, and this statement means it is given, which depends on a particular program. So this will depend on particular program instance, and we are assuming it. So b and d कहाँ से आया? Don't worry about b and d कहाँ से आया. That is something given, and for this we have to do the complete, we need a complete program. तो हम ये assume करके चल रहे हैं कि b and d is live at that particular point of time. So we are assuming it. Please understand, we are assuming it. Okay. So this is a given value. ये दिया program b and d is live here in this case. So and now we are iterating forward. आपका काम है यहाँ से देखना कि after that who is live and who is dead in this case. So b and d is given to us, and this is a local optimization. We are not working around the entire flow graph. तो ये simple example है for a basic block. Okay, moving forward, b d e live हो गया. अब यहाँ पे आइए देखिए, d is getting updated. Okay, d is getting updated. तो d यहाँ पे क्या होगा? Dead हो जाएगा, right? यहाँ पे d dead होगा, but a क्या होगा? Alive होगा. तो in this particular case, अब यहाँ से d gone हो गया, right? Why? Because d is being updated. So this point of the time d will not be live, but a will be live. So this d variable, this b तो रहेगा यहाँ पे, b is already there in this set, but d will be gone because d is getting updated over here. मूविंग ऑन, यहाँ पे क्या होगा, ई इज गेटिंग अपडेटेड एंड डी इज बीन रीड ओवर हियर, तो ये ई यहाँ से गॉन हो जाएगा, वाई, बिकॉज इसकी वैल्यू अपडेट हो रही है, तो एट दिस पॉइंट ऑफ द टाइम डी ई विल बी नॉट लाइव, बट अगेन द सेट विल चेंज टू ए बी एंड डी। यहाँ पे आइए, ए और बी दोनों ही लाइव हैं, बट डी इज गेटिंग अपडेटेड, एंड बिकॉज डी इज गेटिंग अपडेटेड दिस विल सेट विल रिड्यूस टू योर ए एंड बी, ए एंड बी आ गया यहाँ पे। Now here only A is getting updated and C तो anyway it is not here. The only set will remain here in this case is A and B. B तो B is not getting updated. C, but we don't have the C. At this point of the time, B is being read and A is being updated here in this case. So A will be gone and we'll be only left with this B. तो ये हुआ एक पास, हाँ, ये एनालिसिस हुई है. Like we have identified the available expression. Similarly यहाँ पे हम क्या आइडेंटिफाई कर रहे हैं, which variable is live and which variable is not live here in this case. अब हम करेंगे dead assignment elimination in this case. Dead assignment elimination कैसे करेंगे? Okay, so f is equal to e, ये जो असाइनमेंट है, as we have assumed कि इसके बाद में यहाँ पे f is not a live variable, f live variable नहीं है, then what we can do, we can simply eliminate this thing, क्योंकि ये इस पॉइंट ऑफ द टाइम में f was not live, इस पॉइंट ऑफ द टाइम में d is equal to a was live, d was a live variable, d was a live variable इस पॉइंट ऑफ द टाइम में, so that assignment will be not affected. Okay, here e is equal to d, और इस स्टेटमेंट के बाद e is a live variable in this particular set that someone is going to here e is a live variable, so we will not touch this one also. यहाँ पे आइए, d is a live variable over here, so we will not touch this one either. C is equal to a, इस सेट में C नहीं है, in this particular set we do not have C. Okay, तो C has been gone in this case and that means it will be eliminated. इस सेट में there is a A and B both are there here in this cases, तो ये भी जो है आपका eliminate नहीं होगा. So now this statement after dead code elimination, ये बच गया आपका ये particular set. ठीक है, फिर सेकेंड राउंड ऑफ एनालिसिस. अच्छा, यहाँ पे कमेंट लेते हैं आपसे, उसके बाद यू कैन से दिस थिंग, इज इट ओके डिड गुड एलिमिनेशन. पहला तो हमने वी हैव आइडेंटिफाई हु इज लाइव एंड हु इज नॉट लाइव, एंड उसके बाद वी विल जस्ट टेकिंग वन वेरिएबल एट अ टाइम एंड वी आर रिमूविंग इट. एवरीवन प्लीज कमेंट, डू नॉट ओनली वॉच द वीडियो, प्लीज कमेंट ऑल्सो. ओनली भानु इज एक्टिव हियर. Comment. Okay, great. Yes, रिवर्स ऑर्डर में जाएंगे. ओके, एंड देन वी विल बी कीप ऑन एनालाइजिंग कि नेक्स्ट सेट में विच वन इज अवेलेबल. So like here f is equal to f is not available, in only b and d is available. अच्छा, has it been given that here f is available, then we will not eliminate this. f is equal to को हम eliminate नहीं करते हैं, but fn is not there, we'll eliminate this. d is available, so we will not touch this one. e is available, will not touch this one. d is equal to a plus b, will not touch this one. And here c is not available, so we will remove this one also, and here a and b is there, so we will also not touch this one. Okay, so that reduces to this. Again we will do the same analysis. फिर से करेंगे second part. b and d is there, and here d is equal to a. At this point of the time d is dead and d will be gone. a and b, just 1 minute. Yes, Prathamesh, I am repeating it. So now d is equal to a, and इसको मैं complete कर लूँ, then I am repeating it. So now D is equal to A, and D is it will be D will be dead and A will be available, तो A and B. अब देखिए यहाँ पे in this particular set E तो है नहीं anyway, D will be live, तो it will become A B D. In this A and B is live, D will be dead, A and B, and here you only B will be live. अब फिर से वही एनालिसिस करते हैं यहाँ पे, that here अगर आप डेड कोड में जाएं तो D is equal to A, तो D तो अवेलेबल है इसके बाद, तो that will not touch this one. E is equal to D, E is not available over here, E is not available over here, and that means we can eliminate this one. D is equal to A plus B, D is available over here, so we will not touch this one, and A is equal to B, A is live over here, so we will not touch this one also. Okay, so we will not, so this will become this. Last time D is equal to BD, A and B becomes available. A and B read, only A and B is available and only B is available. अब क्या होगा इसमें देखते हैं एलिमिनेशन के लिए, तो D is equal to A, D यहाँ पे अवेलेबल है, D is not available over here, D is not available over here. अब ये भी स्टेटमेंट यहाँ से चला जाएगा, and then we'll reduce the entire thing into only two statement, that A is equal to B and D is equal to A. ठीक है, सो ये हुआ एनालिसिस. अब आप बताइए, ये है इसका फाइनल आंसर कि पूरा एक्सप्रेशन में जो बच गया, that is only A is equal to B and D is equal to A. Only this statement remains, otherwise all other statements are gone. This is your local liveness analysis. Local liveness analysis. ठीक है, अब देखिए पूरा एल्गोरिथम एक साथ देखिए, यहां से स्टार्ट किए थे और कंबाइंड एल्गोरिथम पूरा का पूरा, बार बार कितने इटरेशन करेंगे आप, राइट. सो नाउ दिस बी एंड डी इज अवेलेबल एंड एफ इज इक्वल टू ए. अब हम बार बार वो एनालिसिस नहीं करेंगे. यहाँ पे एफ इज नॉट अवेलेबल, आप रिमूव कीजिए यहाँ से. ठीक है, यहाँ पे क्या हो जाएगा, डी डेड हो जाए, डी अवेलेबल है, इसके पहले क्या होगा, दिस विल ओनली रिमेन. डी तो नहीं रहेगा बिकॉज डी तो गेटिंग अपडेटेड, इसके पहले D will be not live, only A and B will be available. यहाँ पे देखिए A and B है, E नहीं है. ये कंबाइंड एल्गोरिथम है एंड इसको अंडरस्टैंड कीजिए. A and B है बट E नहीं है यहाँ पे, राइट. E नहीं है, दैट मीन्स ये स्टेटमेंट भी वी कैन टेक इट आउट. यहाँ पे आइए, A and B है, रीड कर रहे हैं, D is gone, तो A and B ही आगे जाएगा. ये इफ यू लुक एट दिस, D is again not live over here. D भी यहाँ पे लाइव नहीं है. तो what we'll do, we'll take D out of it and it will only remain as A and B. यहाँ पे A is available, तो C is equal to A. ठीक है, C is equal to A. After that यहाँ पे क्या हो रहा है, C फिर से available नहीं है यहाँ पे, C is equal to A, C is equal to A, C is again not available, we can take it out. और यहाँ पे A is available, तो will remain here और ये स्टेटमेंट यहाँ पे रहेगा. ठीक है, सो ये है इसका एग्जाम्पल, कंबाइंड एग्जाम्पल. फिर से देखिए, बहुत ही सिंपल सा एल्गोरिथम है, यू डोंट नीड टू बी वरी अबाउट ऑल दिस थिंग. मैं मैनुअली करता हूँ, शायद मे बी एनिमेशन की वजह से समझ में नहीं आता कभी कभी. बी एंड डी है यहाँ पे. ठीक है, अब हम यहाँ पे जब आई कम बैक टू दिस पर्टिकुलर स्टेप, यहाँ पे देखिए वी आर एज्यूमिंग कि एफ इज नॉट लाइव. वी आर एज्यूमिंग कि एफ इज नॉट लाइव, दैट मीन्स इस स्टेटमेंट का कोई मतलब नहीं है, वी कैन क्रॉस इट ऑफ. ये नहीं रहेगा. यहाँ पे आते हैं, ठीक है, वी कैन एलिमिनेट दिस पर्टिकुलर स्टेटमेंट. तो यहाँ पे ये जाएगा यहाँ पे. नाउ हियर बी एंड डी इज लाइव. ठीक है, D इज लाइव ओवर हियर. यहाँ पे D तो यहाँ पे लाइव है, हमने एज्यूम किया था इसको, एंड दिस विल बिकम आफ्टर. इसके पहले क्या हो रहा था, D विल बी लाइव हियर, बट उसके पहले क्या होगा, A विल बी ऑल्सो लाइव इन दिस केस. तो जो आपका B एंड D सेट था, दैट बिकम्स A एंड B. यहाँ पे देखिए E इज गेटिंग अपडेटेड बट E इज नॉट लाइव ओवर हियर, तो आप इसको भी रिमूव कर दीजिए. फिर नेक्स्ट स्टेटमेंट में आएंगे, D इज इक्वल टू A प्लस B, D is also not live over here, you can remove this one also. C is equal to A, यहाँ पे भी C नहीं है, you can remove this one also, and A is equal to B, A is available and I can say that this will survive. And but यहाँ पे if you need something, and that will only become here in this case is बी नॉट ए, ठीक है। तो इसी चीज को यहाँ पे कहा गया है। वाई रिपीट कर रहा हूँ फिर से, ई यहाँ पे एफ लाइव नहीं है यहाँ पे, ठीक है। एफ इज नॉट लाइव हियर। अगर एफ रहता स्टेटमेंट सर्वाइव करता, नहीं है, गॉन। यहाँ पे डी इज इक्वल टू ए, डी इज लाइव, तो वी विल नॉट टच दिस स्टेटमेंट। लेकिन यहाँ पे एट दिस पर्टिकुलर इंस्टेंस ए इज रीड, डी इज डेड, तो ये जो डी और ए सेट है वो बन जाएगा ए एंड बी सेट। ई नॉट लाइव, नॉट लाइव ये भी गॉन हो जाएगा। डी नॉट लाइव, दिस विल बी ऑल्सो गॉन। सी नॉट लाइव, दिस विल बी ऑल्सो गॉन, ठीक है। एंड ए इज इक्वल टू बी, ए इज लाइव, दिस विल रिमेन हियर। तो ये पूरा का पूरा जो स्टेटमेंट है ये पूरा का पूरा एलिमिनेट होके यू विल ओनली लेफ्ट विद दिस। मैं थोड़ी सी वैल्यू चेंज करता हूँ एंड ट्राई बाय योरसेल्फ, ठीक है। आप थोड़ा सा यहाँ पे ट्राई कीजिए, रादर देन टेकिंग बी एंड डी, मैं यहाँ पे लेता हूँ एक नई वैल्यू लेता हूँ एंड यू ट्राइड बाय योरसेल्फ। सपोज आई से दैट एफ एंड ई इज अवेलेबल, ठीक है। यहाँ पे एट दिस पर्टिकुलर बी और डी को चेंज करके आई एम टेकिंग एफ एंड ई। कंप्लीट दिस प्रॉब्लम, कंप्लीट कीजिए इस प्रॉब्लम को, ट्राई इट बाय योरसेल्फ। इफ आई एम हैविंग एफ एंड ई अलाइव ओवर हियर, व्हाट विल बी द डेड कोड एलिमिनेशन? यहाँ पे क्या होगा? यहाँ पे डेड कोड एलिमिनेशन एफ एन ई है यहाँ पे। यू डू इट बाय योरसेल्फ। एफ और अगर ई है तो सेम एल्गोरिथम को अप्लाई कीजिए कि लाइव रहे, विच स्टेटमेंट विल बी देयर एंड विच स्टेटमेंट विल नॉट बी देयर इन दिस केस। डू इट बाय योरसेल्फ। सो क्वेश्चन यहाँ पे हाउ मेनी स्टेटमेंट एनएटी का बनता तो है कि यहाँ पे कि हाउ मेनी स्टेटमेंट्स विल बी सर्वाइव्ड दिस एनएटी क्वेश्चन। तो हाँ, एक आ सकता है इसमें, आई कैन से वन एटलीस्ट 1 मार्क का एक क्वेश्चन आ सकता है यहाँ से। सो दो एनालिसिस हमने कर लिया, अवेलेबल एक्सप्रेशन एनालिसिस एंड जो कॉपी प्रोपोगेशन और कॉमन सब एक्सप्लेनेशन दोनों को एलिमिनेट करता है। But dead code is more promising in terms of creating question. What I find here, dead code is more promising compared to this. Okay, so Bhanu statement is there, answer is there. So let's see, F and E. तो यहाँ पे when I go, F survive कर रहा है यहाँ पे, right? अच्छा, नेम नंबर देते 1 2 3 4 5 6। देखिए एफ इज सर्वाइव्ड ओवर हियर। तो जब यहाँ से हम जाएंगे यहाँ पे एट दिस पॉइंट, यहाँ पे तो एफ इज लाइव एंड दैट्स वाई वी विल नॉट टच दिस स्टेटमेंट। लेकिन जब यहाँ से हम यहाँ पे जाएंगे एट दिस पॉइंट ऑफ द टाइम, ओनली वेरिएबल दैट विल बी लाइव हियर इन दिस केस इज ई। एफ इज इक्वल टू ई एंड ई इज इक्वल टू डी। लेट्स सी उमेश, आई होप यू अंडरस्टैंड इट। अब नाउ यहाँ पे बिकॉज एफ विल बी डेड and E is read over here, so F will be alive and F will be dead at this point of the time, E will be alive। E why? Because E reading the value। अब यहाँ पे देखिए D is equal to A, यहाँ तो D live ही नहीं है तो we'll cross it off। then E is equal to D, E is equal to D and E is live here, this will survive, ठीक है, ये survive करेगा यहाँ पे। but यहाँ पे क्या आएगा? यहाँ पे will be only in this case will be D, क्योंकि D की वैल्यू यहाँ पे read हो रही है, right? E is equal to D एंड ई इज लाइव ओवर हियर, मतलब ई की वैल्यू कोई ना कोई रीड करेगा यहाँ पे। अच्छा, यहाँ पे क्या वेरिएबल असाइन होगा? तो ई विल बी डेड बट डी की वैल्यू अब हम यहाँ पे रीड कर रहे हैं तो डी विल बी अलाइव। डी इज इक्वल टू ए प्लस बी, हाँ, डी इज इक्वल टू ए प्लस बी, तो डी तो वैल्यू यहाँ पे लाइव है, वी विल नॉट टच दिस वन। बट यहाँ पे स्टेटमेंट में ए एंड बी ये दोनों स्टेटमेंट ऊपर जाएंगे, डी विल बी गॉन, डी विल बी नॉट लाइव इन दिस पर्टिकुलर स्टेटमेंट। यहाँ पे क्या होगा, यहाँ पे सी अलाइव है, नहीं है, यहाँ पे ए अलाइव है, ठीक है। तो अब आई गेस ए इज इक्वल टू बी लाइव है, और सेकेंड पास भी अगर आप चाहें तो कर सकते हैं, बट एक ही पास में आंसर आ जा रहा है। कंफर्म करने के लिए वी कैन सी डी इज इक्वल टू ए प्लस बी, ये भी लाइव है, ई इज इक्वल टू डी भी मैंने कहा था लाइव है, एंड एफ इज इक्वल टू ई इज ऑल्सो लाइव। हाँ, प्लीज कमेंट करके बताइए। 1 3 4 6 will remain, 2 and 5 will be eliminated, 1 3 4 6 will remain, 2 and 5 will be eliminated। यही मुझे भी लग रहा है करेक्ट आंसर। Comment, Pratmesh, Umesh, your answer is not correct. I believe it is। रिपीट कर देता हूँ, लास्ट टाइम, हाफ एन आवर है, एक और एल्गोरिथम हो जाएगा इसमें। एफ एन ई इज अलाइव हियर, तो एफ तो है, एफ यहाँ पे वैल्यू यहाँ पे अपडेट हो रही है, एन एफ इज अलाइव, तो इसको मैं एलिमिनेट नहीं कर सकता बिकॉज आफ्टर दिस एफ इज अलाइव ओवर हियर। बट व्हेन आई गो ओवर हियर, एफ विल बी डेड, ई विल, वी आर रीडिंग द वैल्यू, ई विल ओनली सर्वाइव। डी इज इक्वल टू ए, एलिमिनेट हो जाएगा, डी इज नॉट इन दिस सेट, एलिमिनेट कर दीजिए। ई इज इक्वल टू डी, ई इज अलाइव ओवर हियर, आई कांट एलिमिनेट, रहने दीजिए। बट एट दिस पॉइंट ऑफ द टाइम ई विल बी गॉन, डी विल बी इंक्लूडेड, डी आ गया यहाँ पे, डी इज अलाइव ओवर हियर, आई कैन नॉट एलिमिनेट दिस स्टेटमेंट, बट एट दिस पॉइंट ऑफ द टाइम डी will be gone and A and B will be available. C is equal to A statement में C नहीं है इस set में, we can cross it off, remove this one, and A is equal to B, A is live over there, and यहाँ पे if I say only B statement will remain and I'll through with this। A is equal to B भी होगा, ये भी, ये assignment dead नहीं है, this is reading the value, ये assignment dead नहीं है, this is reading the value, this assignment is not dead, its value is read by this F statement। Yeah, second and 5 will be eliminated। Okay। No, we do not have a new topic, Bhanu. Sorry to disappoint you. We will have an algorithm which will work globally, globally। ये था आपका डेड कोड एलिमिनेशन। ओके, हाँ, सो कंबाइन एल्गोरिथम वी आर डन। एक मिनट, कांस्टेंट फोल्डिंग, अच्छा यहाँ पे लिखा भी है मैंने, फाइन। सो जस्ट फ्यू मोर फॉर योर नॉलेज। अरिथमेटिक सिंप्लीफिकेशन मतलब एक्स आइडेंटिटीज जो होती हैं, अलजेब्रिक आइडेंटिटीज, किसी के साथ जीरो ऐड कीजिए, यू विल गेट द सेम वैल्यू, मल्टीप्लाई कीजिए एक्स, यू विल गेट द सेम वैल्यू, जीरो को माइनस कीजिए, यू विल गेट द सेम वैल्यू, वन से डिवाइड कीजिए, these are same value। so what we can do, we can this algebraic identities को हम क्या कर सकते हैं, रिप्लेस कर सकते हैं। क्या रिप्लेस कर सकते हैं, रिप्लेसमेंट आपके सामने दिया हुआ है, and this can be replaced by x, x minus 0 can be replaced by x, x divided by 1 can be replaced by x, and these are the arithmetic simplification आप कर सकते हैं। this is one of the optimization technique। another is strength reduction, भी one of the optimization technique है, where algebraically optimizations include local reduction in the strength। reduction क्या होता है, reduction in strength means replacing high cost operation with low cost operation, high cost operation with the cheaper operation। तो जो the algorithm for exponentation, a square can be replaced by multiplication, division can be replaced by multiplication। so these are expensive operation and we can replace it by the cheaper one, and that is your strength reduction। constant folding इसके पहले आ गया था, ठीक है। so evaluate the expression at compile time if they have a constant value। तो when we are compiling it at that time, only 3 multiplied by 4, we know that it's a constant, every time it will not be calculated and it will become x equal to 12। ठीक है, so that was the idea, or this was the question that I was targeting, and it is now here। I believe that we have already done। so basic block मैंने आपको बता दिया, the statement is true। available expression analysis ये मैंने आपको बताया है, and that is for common subexpression as well as constant copy propagation. Okay, copy propagation. एंड लाइव वेरिएबल एनालिसिस भी बता चुका हूं मैं डेड कोड एलिमिनेशन के लिए. दिस इज नॉट अ कॉमन सब एक्सप्रेशन, दिस इज अ कांस्टेंट फोल्डिंग. 4 मल्टीप्लाई बाय को आप 20 कर दीजिए एंड इन दैट केस आंसर वाज डी. आई होप दिस क्वेश्चन इज नाउ मोर क्लियर टू यू. Okay, last is your global optimization, and I want to I do not have that much time to cover the theory part. There's a lot of theory out there. Okay. Okay, let's see how much we can cover. So quite few topics are there. Let's see. So the global optimization will be work on, let's see how much we can cover. Then I want to cover this complete. Let's see, half an hour is there. How much we can cover? Theoretical aspect is there. Okay. So now global optimization, define an analysis on the basic block where D is the direction. D is the direction. You see that available analysis was a forward direction and liveness analysis were a backward direction. V is the set of values program can have at any point of the time. Values, variables. And F is a family of transfer function that will define that. Here in this example, there is some function we are applying on this particular statement, and this set of inputs, okay, is being transformed into BDE. Okay, BDE variable. This variable, some transformation is there, and then we change this variable to BDE, and this is what it is calling as. F is a family of transfer function, and that will change the variable to variable. I is the initial information, top or the bottom of the block. So this analysis, the local analysis, we are formalizing it, and it will be expressed by DVFI. What is D? Is the direction. V is what? The set of variables. F is what? F is a function that will transform the set of variable, and I is the initial value that we are assuming either at the top, empty for available expression, or bottom as we assumed B and D in this particular case. Okay. So there is some sort of transformation that is happening here in this case. Okay. Now, direction backward, domain is set of variable D, transfer function is a set of variable, and the statement A is equal to B. See? So we have a variable and we are analyzing the statement, and what we were doing that B and C will be read, so it will be alive, and A is being updated, so it will be dead. So in the next function that we are doing, transfer function, we are having a variables and a statement. So remove from A from V, any previous value A is now dead, and B and C will be added into V. Any previous value B and C is now live. Formalization is there that V से हम A minus कर देंगे, इस set में जो भी दिया रहेगा. Same thing है, please understand. Maybe technicalities जब आती हैं तो थोड़ा सा mathematically understand करना difficult रहता है. But we are doing minus A if it is present, but union is with B and C. This is the formal. Initial value depends on the semantics of the language. What is available over there? So this is the formal way of expressing the previous thing. It is not a new thing. I am just explaining the same thing. Rather than in and out, हम थोड़ा सा backward direction में जा रहे हैं. Okay. So now यहाँ पे we have few variables. यहाँ पे we can see that few terms. In is the function where some variables are available. Prathamesh, I guess no. Okay. So guessing wise, guess हम कैसे करते हैं? Guess I am doing it based on the previous analysis. You remember that there is one question based on cylinder, the triplet, the cylinder number, and then the surface number and the sector number, C, S, and H, I guess. So this there was in 2013. there was one question based on this arrangement of a file, and it was very difficult question. Arrangement of a file in a hard disk of a cylinder. Okay, so अब guess कैसे करेंगे? पहले आया है तो now this time also it will come. Okay, this time also it will come. So my answer is yes, there may be a chance that there will be a question from secondary storage. So based on the previous one, I am explaining it to you. And yeah, there is a chance, 50-50 chance, 50% chance that there will be question from secondary storage. And let me remind you that also there is no question from secondary storage. I guess till 2015 there is no question from direct question in the secondary storage. So now that makes it more probable for this year asking question from secondary storage. Pratmesh, I guess I have answered you. So now we are defining few function here. There is some v is the final, there is an input v, and out variable will become this v minus a. Okay, v minus a. V in is the complete part. V in will be the complete part, but only thing is backward direction. We need to take the backward direction. So in and out will just have a different meaning. This is the entire in variable which will become out in the reverse direction. V out, this will become basically the in variable because we are going in the reverse. What we are doing, we are subtracting a from the variable list and we are doing with b and c. This part is the kill n. The variable which will be not live will become kill n. This part is the generate n, that we are going to generate new variable, and this is the input that we are assuming that they are live. So from that we'll take a minus union with bc, and that will be your final output. तो ये भी क्या है, this is also formalization. ये भी formalization है, और आपको I think in out kill और generate gen n की meaning समझ में आ गई हो, because we will use this one for the next point. यहाँ तक मेरे को जाना है and I want to go up to there, to have patience. Okay, so now out n is equal to what? Out n क्या हो रहा है यहाँ पे? This out n is equal to union of your input n, if where p is the successor of n. Okay, now so in is the set of live variable enter into the basic block. Out n is the set of live variable coming out of the basic block. Generate n, all the variable that is on the right hand side but not on the left hand side. Okay, all the variables which are on the right hand side but not on the left hand side. This is very important point that we will use. ठीक है, formal definition में भी नहीं जाते हैं. ठीक है, we don't go into this. Gen n is what? Gen n is all variable that is on the right hand side but not on the left hand side. Kill n is the set of the variable which is getting updated. So as I said, a is equal to b, so that b will be gone. So kill n is the set of variable, is in this case is a, those values being read. So set of variable on the left hand side whose value is being read. So I think आपको पता चल गया होगा kill n, what is your kill n, what is your gen n, whose value we are being on the, क्या है gen n, on the all the variable that is on the right hand side but not on the left hand side. Okay, so this is gen n, and now we are ready for our global analysis. Global analysis. मेरे को कहाँ तक जाना है? Let me tell you my target. I want you to make sure that you are able to solve. Just 1 minute. 1 minute. So I want to just solve this particular question. यहाँ तक I want to go. Let us see whether I'll be succeed or not. But this question is from 2015, and this particular question is about liveness analysis of global variable. थोड़ा सा patience रखिएगा, and I want to complete till this one. At least then I can complete till the algorithm part. Now okay, global analysis. Global analysis will now work with the control flow graph as whole. Okay, local we have already seen. Now we'll look at the global one. Certain optimization are possible in global analysis and that are not possible locally. Okay, that is something like code motion, moving the code from basic block to another one, avoiding computation unnecessarily. So the example that I have given was the lazy coder. Okay, so lazy coder was that example that was only possible with the global analysis. Now यहाँ पे देखते हैं विदाउट लूप है, ये सिंपल है, विदाउट लूप में आपको प्रॉब्लम नहीं होगा, ठीक है. सो नाउ सपोज वी आर एज्यूमिंग दैट एट दिस पर्टिकुलर इंस्टेंस एक्स वाई इज लाइव. ओके, तो यहां भी एक्स वाई आएगा. नाउ अब आप देखिए, या तो आप वैल्यू कंप्यूट कीजिए. ओके, फॉर्मूला से क्या फॉर्मूला था, ये है आपका इन सेट है, ये है आपका इन, ये है आपका आउट, यहां पे आएगा आउट. देन वी विल राइट जनरेट एंड देन वी विल राइट किल. ओके, तो जनरेट एंड किल वी आर गोइंग टू राइट दिस थिंग. अब आप इसमें या तो इस फॉर्मूला को यूज करके कंप्यूट कीजिए द वैल्यू, और यू कैन कंप्यूट द वैल्यू मैनुअली. ठीक है, मैं आपको बता देता हूं बिकॉज यहाँ पे एक जगह कंफ्यूजन होगा, दैट आई विल रेक्टिफाई. बट नाउ यहाँ पे यू आर अपडेटिंग द वैल्यू ऑफ एक्स एंड वाई एंड यू आर रीडिंग द वैल्यू ऑफ ए बी सी डी. ठीक है, सो नाउ इसमें से क्या होगा, माइनस जो इन का सेट है उसमें से हम माइनस क्या करेंगे, एक्स वाई माइनस करेंगे और यूनियन करेंगे जनरेट, जिसमें ए बी सी डी ऑल रहेगा. तो देन इन दिस केस ए बी सी डी विल बी द आउटपुट. ठीक है, ए बी सी डी. तो सेम चीज कर रहे हैं, बट नाउ अब जनरेट एंड किल से आप थोड़ा सा यू कैन यूज द फॉर्मूला दैट इन सेट में, ये आपका इन सेट है, ये आउट है, बिकॉज वी आर मूविंग इन द बैकवर्ड डायरेक्शन. तो इन सेट से माइनस कीजिए, डू द माइनस ऑपरेशन ऑफ व्हाट, आप दैट इज दिस किल सेट. किल सेट को माइनस कीजिए, एक्स एंड वाई विल बी किल्ड, एंड यूनियन किससे कीजिए, ए बी सी डी, द वैल्यू दैट यू आर रीडिंग. ठीक है, नाउ यहां पे भी एबीसीडी आएगा. ठीक है, एबीसीडी आएगा. नाउ हियर अब यहां पे देखिए एक्स इज बीइंग किल्ड, ए इज बीइंग किल्ड. तो एक्स तो यहां पे किल, एक्स तो ऑलरेडी डेड है, यहां पे वी डू नॉट हैव द एक्स ओवर हियर. ए विल बी किल्ड हियर. ठीक है, और यहां पे व्हाट वी आर वैल्यू यूर रीडिंग, बी सी एंड डी यूर रीडिंग. तो ओनली वी आर लेफ्ट विद दिस पर्टिकुलर सेट. तो आगे हाँ, व्हेन वी मूव फॉरवर्ड वी विल बी ओनली लाइव विद योर बी सी एंड डी. ठीक है, इधर आते हैं ए बी सी डी, वाई इज नॉट देयर. A and B has been read here in this case, so A and B will be live here in this case. तो यहाँ भी आ गया आपका A B C D. Now here the thing will become the union. B C D and A B C D, all live variable will be present over here. That is A B C D. Now what we'll do? इसमें loop तो है नहीं यहाँ पे. So C and D is live over here, और B and E, तो B तो चला जाएगा, B तो यहाँ से चला जाएगा, and we are only available with A C and D. ठीक है, A and C, A C D that will be left out over. तो सेम एल्गोरिथम है, जस्ट वी आर वर्किंग हियर इन दिस केस एज अ कंप्लीट कंट्रोल फ्लो ग्राफ. लाइवनेस एनालिसिस करते हैं आप में. ठीक है, अब आप कीजिए एनालिसिस. यहाँ पे आते हैं, यहाँ पे बी एन ई, अच्छा यहाँ से चलते हैं. सो वी हैव एज्यूम दैट एक्स वाई इज अवेलेबल बैकवर्ड डायरेक्शन से. सो एक्स वाई इज अवेलेबल, सो एक्स वाई लेट द एक्स वाई विल बी, दिस स्टेटमेंट विल नॉट डू टच एनीथिंग. यहाँ पे देखिए ए बी सी डी. ओके, ए बी सी डी, and in this case x is not live over here, no? But a is live over here, but this is not live. So we can safely remove this part. और क्या remove होगी, okay, this remove this particular part, remove कर दिया हमने. यहाँ पे आइए, y is not available, in this case the entire y part will be removed in this case. So now the one flow direction is there, that will be completely eliminated. यहाँ पे आइए, e is not live over here, e is not live, and we can completely get rid of this e over here. D is live over here, so we will be stopping here. Okay, so now I'll remove all this information and this block will become this. I don't have this path and we are only left with this particular. Comments. Same algorithm, same algorithm. Okay, but we have now V in and out, V in, V out, generate, kill. Okay, and these are few variables that are being used, okay, for this, but in and out will be from the reverse direction. ये भी वही है. This is also simple. The only thing is the formalized very properly in this case. Comments are appreciated. is the issue. Okay. Oh, come on. Okay, so I'm live. Okay, fine. Sorry. Now, let's A is here, and what we'll do. So now we are dealing with loop, and initially we are assuming that every block is empty in this particular case. And now we are analyzing this block. Now here x and y is dead, so anyway it is dead. A is live over here in this particular case, and we are reading the value of what? A, B, C and D. Okay, so definitely here A, B, C, and I think A, B, C, D is there. Y, okay. I think I have done it wrong. I think it should be okay. Okay. Just 1 minute. I think it is wrong. Okay. I think I can take this is okay. Sorry. Okay, so here let's see this part, and here x and y is not live, but here a is live there, and here a, b and c value. Okay, I've changed this to d, maybe my mistake. Later maybe I'll see what is happening here, but I think that is changed. A, b and c is live. A, b and c value, and this value assume as b here in this case, that is changed. Now this value will pass on, so here it will go, and here now A is been updated. Okay, A has been updated. A will be not live here in this case, and here the value that will be live here in this case is okay.